Okay, we are live. This is the e-NABLE R&D Hangout for 2015, April 27th. And welcome aboard. We have Skip and Jason and Arden with us today. And we'll probably have other people as they join up. So you said you had some fingers, or I asked if you had some fingers that you could show us. Jason?
Actually, I've got a whole hand here.
Awesome.
Right, because this is the dental elastic system, so it has to connect to the hand. It closes pretty well, but as you can see, there's things at the knuckles also.
Right. Similar to the clips on the Falcon.
And a rubber band just broke, so this finger isn't going to go very well. It's good to get that out of the way quickly because I'm using the wrong rubber bands. They specifically told me to get the heavy-duty ones. I got the medium ones, and the heavy ones are on order. So this is not good for evaluating the strength of the rubber bands. It is good for figuring out that one of the things I did with the Raptor has a sharp corner right here. I just figured that out this morning. Every time they bend, they have to bend around here. There's a sharp corner where the post turns into the regular, so it's rubbing against that. So I can look at that and put that down as something to work on.
Right.
But the basic idea is from the Falcon hand guys, and that's that you have posts. I downloaded one of the Falcon hand designs, and I printed one of the fingers a while ago. And immediately one of the little posts that you put the rubber bands on broke. They're way too small. So I made my posts much bigger. They seem to be very strong. And it works pretty well. By the way, putting a 100% hand on your hand like this is awesome. I walk around the house trying to pick things up. So
that's great.
Yeah, I just use the fingers to test it out. It's a great way to try and do things, but I can usually pick up like my mouse pretty easily, my computer mouse.
Yeah, terrific.
Yeah, so it's a good way to test, but I've been pretty happy.
Do you have adaptive gripping on that? I couldn't see if you have a Whipple tree.
Yes, I do. Yes, I do.
Yay! All right.
Yeah,
awesome.
This is the standard design, and actually I'm going to be printing out a new one of these today, because I want to try something, and I don't have to rewire the elastics. I just put the little rubber bands on. That's much easier. So this will be my test hand now.
That's terrific.
Yeah. Oh, another thing that I've also got adaptive grip on is a new Raptor wing design.
Wow.
I put a box on it. Huh?
You've been a busy guy. You keep that printer humming.
Yes, I do. I've been trying to do too many projects at once, especially because this one I'm working with Nick Nolan. He made a cuff that doesn't have nearly as much stuff on the back. It only needs 2 wires because of the adaptive grip. So Nick made a nice cuff and a nice interface piece that simplifies the whole thing. So this should fit under a shirt a little bit easier.
Yes.
Go ahead.
I just said, I was just agreeing.
Okay. I'm thinking that maybe I can make something even smaller. I ordered some leather a while back. I want to start working with that for gauntlets, but also it might be good for the rip cuff. And then you'd have something that's just this piece. So it would look like this would be the printed part, and then you just have a leather strap that you strap to your shoulder. I want to see if that can hold on well enough. If it can, then it would be even smaller and more adaptable. But for right now, we're working on this, and it works pretty well. I don't have the strings tight enough, but you've got adaptive grip on the wing and a slightly smaller cuff.
So for the wing, like how much of a residual limb do you normally have on that? So is it like cutting off before the elbow?
The way that the Raptor wing people phrased it is that they wanted it for people whose palm is too small to really get a good grip, or they don't have a palm at all, so they have no hand, but their arm is much too long for a RIT cuff. So somebody who's cut off about here needs the RIT cuff, but somebody who just has it up to here might be better served by a wing. So I have not had any contact with the team. I tried to, but they seem to have gotten a little busy. I believe they're students who are working on other things, so they haven't had a chance to answer any questions about it, and they told us that when they put up the design. So I don't have anyone right now that I can test this with. I might at a later point, but I'm just trying to get this design to a point where people can look at it. I need to show it to Nick right now and let him look at what he did with the cuff. And then if that goes well, I can post it to the community and see what people think. But it's not quite at the level where I would give it to someone yet.
Okay. Right. It looks really cool, though.
Yeah, it was a good idea that the wing people had, and I just kind of added a box on it so it could have adaptive grip. And hopefully Nick and I can make some more improvements to the cuff system.
Yeah, I really like the idea of print flat and thermoform PLA cuffs. So think about that. It's really strong, and you know.
The problem is it also takes up a big print bed. My print bed is barely big enough for anything a little bit bigger than this cuff, and this is only 100%. If you lay it flat, I don't think I would be able to do a 125%.
Hold it up so I can see it again.
Well, the cuff is this big. Okay.
Yeah.
And that takes up a pretty good bit of my bed. So I definitely couldn't print a flat one for an adult, but I'm pretty sure I couldn't print one for most sizes because it's only 145 millimeters wide. My bed is. So
yeah,
that's why.
I've got a fairing that's about 7 inches by 7 inches when it's flat, and you can't get that on your bed. I've got an 8-inch bed.
My bed's only 6 inches wide.
Yeah.
That's why I've got leather ordered. I'm really interested in seeing if I can make a nice simple thing where you connect printed parts to a piece of leather and just wrap that around your arm.
Right.
But that's experimental too. I haven't even gotten the leather yet.
Right. Well, I still recommend you take a look at redesigning whatever you can get on your bed and print it flat. It's so strong, and it's easy to put under a sleeve. You know, I mean, it's.
Oh, sure.
Yeah, it's thin.
Okay, well, that's pretty much what I had to say. So the rubber band system is going pretty well. They are easier to put on. I'm working on the slots right now to make them a little longer so it's even easier to put on. It is a little ridiculous when you get up to adult-sized hands. This is a 175% finger with a normal rubber band in the grooves.
Yes.
Yes, the grooves are just ridiculous. They look kind of silly. This is actually double looped in some places, so it's just a ton of room. That's something that might work with parametric design so that these don't get as big as the fingers do.
Mm-hmm.
But that's a project for a later date.
Yeah, I last summer was playing with the Falcon hand when it first came out, and I had trouble with my crude little built 3 years ago from a kit printer printing the little tiny grooves. I just didn't have the resolution the way I was running my printer, and you know I was able to get some testing, and I really loved the way it worked with the rubber bands. But the bands didn't last very long. They seemed to deteriorate. The rubber deteriorates out in the sunlight and the air, and so they have to be replaced fairly often anyway. But
yeah. The regular rubber bands I'm using, I've gone through a bunch of them already. Hopefully the heavier duty ones that they recommended will work better. So that's what I'm looking forward to testing. So this is an interesting project. I'm not entirely sold on it yet. We have to make sure that you're not replacing bands 3 or 4 times a day.
Right. It's certainly worth investigating, though. There's a lot of good things about it, and you know, if we can overcome any problems, that's great.
Right, and one thing that was very useful is somebody volunteered to test out several different sizes of rubber bands because they're not just strength, but they also have different lengths. So these are too tight, and if you find some that are just barely small enough to hold the fingers up, that's really what you want. They won't be pressed as hard each time you use them, and it will do better.
Right. So where are you getting them? You getting them from a dentist, or you order them on Amazon?
Yeah, you can just go on to Amazon and order different sizes.
That's where I got mine.
Yeah, so it's like $5 for a bag of 50. If the system works out, you can just order one bag for each recipient and just hand them a bag of 50, and they'll be good for the life of the hand.
Right. Sounds good to me.
Yeah.
I'm finding that I'm using the heck out of my Amazon Prime account to order parts. Free shipping's kind of nice.
Yeah, I'm also interested in the crimping system that the Falcon Hand has, so that you don't have to tie knots. The thing that bothers me about that is it has to be parametric. If you just scale it up, then the spaces will be too big, and it won't hold the wire in place. So I like the idea of it. I'm not sure I like that you have to have it parametric.
The parametric puzzle is something that I've been thinking about a lot lately, especially with the Hand-O-Matic guys. I probably ought to spend more time talking to them, but they've all been pretty busy. One of the things that somebody brought up in one of our recent Hangouts that sounded like an interesting idea was using OpenSCAD with STL files to make the holes for things to go through parametric, to have a fixed size shape subtracted from the other shapes.
Right.
And that might be a programmable way to still use STLs for the model, but still be able to have certain pieces of the model be parametric in their design.
Well, I can't get in 3D where I am, so if there's an alternative way to do parametric work, that would be very useful.
Mm-hmm.
Yeah. It has to be pretty simple. You know, no knowledge of software and OpenSCAD.
Right.
I don't do those things.
I'm talking about back-end for the Hand-O-Matic more than anything.
While I've got you guys, there is one thing I'd like to discuss. There's one more thing that bothers me about our hands. What I've noticed is that because of leverage, they pretty much always bend the fingertips first and then bend together. And I feel like that's the opposite of what we want. I feel like generally you want to bend at the palm until you meet resistance and then start bending the fingertips around something.
Okay.
But I have absolutely no idea how you would get the hands to do that.
So here's a couple of brainstorming ideas. Thicker rubber bands, farther out. Close to the palm.
I thought of that. The thing is, when I press on the hand, there's actually quite a bit of resistance that really wants these proximals to bend first. It feels like nothing's really pulling on the proximal to pull it down until the fingertips have been pulled down. It feels like there's really no leverage pulling this because this is eventually what leverages this down.
Yeah, I'm not sure. I've got to.
This might be just something to think about for the next week and then talk about.
Yeah, I think there's an answer to that, and I think it's a good thing to work towards. It probably has something to do with the attachment points and of the tendon. And
yeah, I feel like all the force is just getting pushed through to the fingertip until
Right.
that fingertip is locked, and then it pushes the proximal down.
yeah, I think you're right. So there's probably some geometry we could mess with the knuckles and the hinges there. That'll
Yeah, you're
allow us to mess with that.
wondering if it's just a leverage thing. The outer fingers, and the outer piece of the phalange has a smaller leverage point, so when it pulls down, it has less inertia. I'm not able to express that very well.
No, I understand. It's a tricky bit of leverage and inertia there.
Actually, I've got a basis for playing with it. I can't tell from this, but I've got some different stringing things that I'm doing with the whipple tree inside of the palm, and so I'll take a look at that. Thanks for mentioning it, Jason.
That's probably what it is. All of the tendons are going across the back of the hand, whereas in our hands, the tendons are in the palm. I'm wondering if that's what's causing the difference with the way it moves. The fact that tendons in a human hand are in front of the bones for the...
Yeah. And it's not necessary that the tendon's got to go all the way around to the back of the hand. You know, when you're making an arm. I don't know if you can see this.
Yeah, I can see that.
But I've got my tendons running to the whipple tree way out in front, and that might come closer to doing what you were asking for, Jason. I'll just have to take a look at it.
Yeah. All right, well, I've got to get going, but it's been good, guys.
Yeah,
All
it
right.
really has.
Joining us.
Hey, Jason.
All right.
I always like to see your show and tells, Jason.
All right. Bye, guys.
Oh, yeah.
See you in a couple weeks. Wonder.
All right.
I mean, the only other thing I can think of for that is maybe like running an extra wire underneath the bottom, in addition to the elastic wires we're already running, and then have that one pull or not break first, but like be the one to go first because it's like the elasticity. So it would be the first one to bend. I mean, that would require more SolidWorks drawings there.
Yeah. Can you see what I've got going here, Arden? If I pull straight out this way, I'm definitely going to bend the proximals first. You know, they got it. And so it depends on how you route your tendons.
Okay.
And we may have some latitude when we don't have a child's residual palm in here. Like if we're making a hand on an arm, like I'm doing here.
I wonder if there's a way that we could route the line through a solid palm piece, like a palm plate in front of their hand that they're pushing against, with the tendons running through it.
Yeah, why not? Especially like the flexi hands that Steve Wood's been doing. He's got a palm taking the place of like the Velcro or the leather. You know, he's got a printed palm, and you could run your tendons around that. Seems to me.
Yeah, they would have to be inside of the palm because otherwise you have them sawing against whatever you're grabbing.
Right. But
Or
you still have an opportunity to get that angle of pull
more forward
on the tendons from the attachment point at the distal knuckle of the phalange there. And it looks like a fun project. I'll get to it eventually.
Yeah,
When you got time.
I think the way our lines are wired, the way the tendons are wired, they go over the back of this knuckle, and then they go through the front of the other knuckle, right?
Right.
So that's also, that would explain why this one moves first rather than that one. Because
Yeah, I think so. I think so. So just fortuitously, the design that I've been playing with my adapters to take an ordinary Raptor or a Raptor Reloaded and build it into an arm. I think I've got something going there that'll make it easy to experiment with that.
Right. So what I'm thinking is, if even if the strings are coming in from the back, if we found a way to route them in front of the joint before they go into the finger, that might produce the same result as what you're doing. I don't know. It's just random thoughts. It's not.
Yeah, and the straighter the path, the least friction and bending resistance and all of that you're gonna have. So that's what I was trying to get with my my hands is to get the straightest path, as wide open, low friction as I can get.
So you were the hand you were showing. You told me earlier that that's a normally closed hand design that you're working on.
The yellow one here is currently operating as normally closed.
That's cool.
So I've got a rubber band that's pulling on my whipple tree. So it's always gripped. And the way it works is I've got another pulley that goes to my Bowden cable, and so when I pull on the Bowden cable, it pulls the end of the rubber band towards the fingers, taking the tension off of the whipple tree.
Oh, that's cool.
And so it's really working.
Yeah.
and getting the geometry.
But it's still
I'm working on one with sewing machine bobbins to use for little pulleys.
Oh, cool. But yeah, you're working with the RIT arms, so that gives you a lot more leeway in what you're doing with the routing of the tendons through the hand and through the wrist.
Right. Well, actually, I'm working with the Raptor Reloaded mainly right now. This is just an ordinary Raptor Reloaded with my adapter.
Cool.
And so, I can take this Raptor Reloaded right off of this hand and plug it right into this arm.
Cool.
And while I've got the floor, this is what Jeff Ehrenstone and I have been working on together for the past couple of months, and it's all come together. This is the famous Monet socket.
Right.
That he starts with a cone and thermoforms it to fit onto the plaster casting of the patient's residual limb. And I've got some video of him doing that. So the whole thing is modular. This arm can screw right onto the socket from anybody's prosthesis because it's a standard size nut and it's a standard size bolt.
Yeah.
That's really cool.
And so you can, Arden, the idea is these prosthetic devices for somebody that's like a transradial, below the elbow amputee, are usually operated by a shoulder harness. So you shrug your shoulder to make a pair of hooks open up, and there's a rubber band that keeps them pulled together. I don't know if you've seen that. It's made by a company called Hosmer, is the American company that makes. So they're known as the Hosmer hook, and that's just one of many kinds of terminal devices for this prosthesis that the practitioners are normally providing to amputees, and they just screw on and off, you know, with this kind of screw. So you can screw off your hook and screw on a Raptor reloaded with an adapter and the right kind of bolt on it, and, you know, replace a hook with a hand. We're getting there. You know?
So this part right here, like that's attached to your molded part, what is this part right here? The black one.
So this is just a linkage that was making the arm the right length, and also just a piece of pipe essentially. But it also is going to have some mechanisms in it for the rubber bands to make the normally closed grip, which I think is very desirable. You can imagine, you know, if you want to ride your bicycle, you don't want to be in a strain while you're holding onto the handlebar. You'd like to be able to take some action to grab the handlebar and then relax and let the rubber bands maintain your grip while you're riding around. Same thing for holding a fork or a spoon. You know, you don't want to be in a strain to hold it. You'd like to take some action to open the grip and then relax while it maintains it. So being able to get this normally closed grip, I think, is a real important breakthrough. And if I can get that worked out, you know, that's going to be really good for your myoelectrics too. You know,
Yeah.
If your myoelectric has a similar kind of tendon arrangement, so you've only got one motor that's pulling all your fingers to grip, and something that's causing them to spring back. I don't know how your hand works. Are you going to be able to show us your hand today?
I don't have it with me, but I do have a few videos of it that I can show you guys with a screen share.
Okay.
But I mean, does that mean I'm leading into that, or do you have anything more, Skip?
No, go ahead. I got some video that I can show, but it can just as well wait till the next meeting 2 weeks from now, and I'll have it more organized. So if you'd like to go for it, I'd love to see what you got. And by the way, hi, Les.
Hey, Les.
Hey, Les. Good.
He ain't got his earphone on yet.
There we go. Hey, Les.
Hi, everyone.
Hey.
Can you hear me?
Yeah, hear you just fine. And Art's going to show us some videos of her hand next, I think.
Okay.
I'm trying to learn how to do screen share.
There's a, on the left-hand side of your screen, second icon down is screen share.
Okay. This work?
Looks like it.
Okay.
Yes.
So, let's see if I can find it. We'll decide to load. Okay, so this is actually one of our guys in our project, and he's going to show you how to play because my computer is being a pain. Of course. One sec. Oh, Lord. Okay, well, I may not be able to show you video, but
Try refreshing the page.
start refreshing it.
Arden, did you hear trouble by refreshing? Oh, you did. Okay.
Yeah. There we go. Okay, so that's not the best video of it, but it's basically a, I've got another one here which is going to be better. But It's a normally closed hand that functions via an Arduino, which you can see right about there. We've got an Arduino going to the amplifier. All of the MIO devices are located on his forearm. And then it's normally closed, so when he actually flexes his muscle to go into an open formation, then he can grow back down. And then we did a little bit of a redesign, it's all based on the rafters. So, well, this is our
mute everybody else so that we can eliminate the echo for a second. So there's a feedback loop, but I think that if we mute everybody but you, we might be able to.
Okay. All right. So, basically, here's our new design. So it's the rafter hand, and then it extends outward. So it starts at the palm right here, and then it just extends face outward. And then we're going to, from the tensioner, which all the strings are coming from here, we're going to the tensioner, which the string's wrapped right in there. It goes into the servo motor, and then the servo motor's completely housed within the extended plate, and then all of this goes outwards. And then in order to do this, we also redrew, or one of our members, Beth, she redrew every single SolidWorks part for the rafter hand, so it can be edited via SolidWorks, so we could get the exact dimensions for all of this. We have all the solid parts. It should be almost automatically drawn to scale. She spent like 40 or 60 hours trying to design this, so it's pretty much drawn to scale. And then in addition to this, our teachers were like, okay, you made the hand, that's great, but they actually wanted to do engineering for our engineering project, believe it or not. So they also had us work a little bit more on the engineering aspects, which I'll show you some of our results we found. So we found that to pull each of the strings, it actually required 4 pounds, which meant that we needed a servo motor of about 60 inches of torque, I think. It was, I think, 60 ounce inches of torque that we needed. So that was our original motor, and then we ramped back up to 150. And then as far as engineering results, we did a little bit of work with material ABS plastic, and we found that in addition to some other results, that we found in a online thesis statement, we found that the tensile strength of the ABS plastic, when pulled in the manner that we had, which was horizontally, so with the grain, was actually just as powerful or just as strong as if you injected mold of it. Now, if you pulled against the grains, we weren't able to conduct that test due to our dimension printer being a pain. It just didn't want to print correctly for that day that we were trying to print it. But it's actually, if you look down here at our tensile test, it's pretty comparable to the ABS plastic injection molding, which tells us that, I guess, in the majority of ways that our hands are going to be tested, it should be fairly comparable to anything that's just solidly printed. And then we also did a little bit more testing in the actual fingers. So what we did was we basically took we did this in SolidWorks as well, but we took a finger, each of the fingers, and we put a force down on it. So this was actually via a tensile test. We just continually put force on it until it would break. We found that about an average, each finger can hold about an average of 10 pounds force before it deforms, which is pretty comparable to what we found in SolidWorks, and it's going to break right around the flange area, if you see that. And that was just about what we found in SolidWorks, except in order to do SolidWorks, because it's just a pain in general, and it doesn't like holes, we had to make this a solid part. So we found that it actually broke at about 4, but that makes sense, and it broke in the same exact area. But it makes sense that it broke around 4 because it's not factoring in all the gaps you have, so it's going to have a lot more give in real life comparison than to what we found here. Other than that, we did a lot of electrical, so found all the electrical components, did a lot of batteries, worked with servo a little bit, and then here's like a final look at the housing that we designed, which you guys are more than welcome to have if you guys want it. We have all the schematics and how everything works if at any point in time you guys want to look at it. But, I mean, that was the majority of our project, and we're pretty darn proud that we managed to make that work somehow. But, yeah.
I would be proud
to ask a question. Can you hear me? Am I on now?
You are on.
Yeah, all right. First of all, this is great, and your voice was breaking up, so I'm not sure I caught everything. Can you give us a link to that beautiful piece of work that you're showing us there? Is that like a PDF or something that you can share with us?
This right here?
Yeah.
It's actually a Google Drive. It's a our final project presentation on Google Drive. So I don't really know what would be the best way to do that, but I can send it to you guys, no problem at all. I just don't know how to, who I should send it to, I guess.
So your voice is breaking up on my end here, so I'm not sure I heard you. Are you able to share that with us, or share it later, or not at all?
She said she could email it to you.
Oh, okay.
Yeah. In the upper right-hand corner, Arden, where it has the share link, if you click on that and go into advanced, you can change the default setting where instead of specific people, you can make it be anyone with a link, or can view anyone with a link is the way I usually do it.
So anyone with a link can look at it.
That way you can share it so that people can see it but not make changes. And then if you want to allow people to edit, you give them specific permission to do so.
Okay, perfect. You want me to just throw that in the comments then, I guess?
Might as well.
Alright, so is it the chat message or the Q&A?
Put it in the chat message because hi, Bob.
Hi, Bob.
So that's what we've got so far. I mean, I can walk you through any other parts that you guys are interested in about it, but you guys have the link to our PowerPoint.
Okay, thank you.
Arden, that was amazing.
Oh, thanks.
You should be really proud of yourself. You advanced everything, you know. I mean, the state of the art and all that stuff.
Oh, trust me.
I can't wait to understand it, and so I'm going to have to study it a little because, like I said, the audio and the video was less than optimal on my end watching you, and I'm really excited to learn about it. Can I ask you now if you will explain to me, does your servo motor pull the flexing tendons the way an ordinary raptor hand does, and the fingers are extended by elastics, or what's the mechanism there?
So the entire raptor hand basically we have it closed. So how you would normally, you'd flex your wrist, it would normally close all the way. It's a normally closed system. So then as you flex your muscle, it goes into an open system. But everything as far as the raptor hand in front is the exact same as what you currently have. So I think the only difference between the actual SolidWorks design is an extension of the arm.
That's the same philosophy that I've been using with the things that I've been working on. So that's great. So we've got a lot of things going in parallel, and we ought to be able to share back and forth between what I'm doing and what you're doing, and help each other solve some problems that we've run into. So that's great. I'm not messing with myoelectrics. I'm just whole body powered. But I do have this adaptive grip with the Whipple tree, and there's some value in that you may be interested in. And so I can't wait to understand. We'll need to be in touch. Maybe do a personal private hangout between the two of us sometimes. I would like that.
I'm sure my entire group would like to join in on that because they've been a ton of help.
Yeah.
But we'd probably love to do that.
Great. Thank you.
Okay. Yeah, the normally closed makes a lot of sense to me, especially in in any context. The problem with an electrical system for making the fist is that you're draining battery when you keep it closed, and doing it the other way with a normally closed hand, you're only draining battery when you're reaching.
Right. That's a good point. And I think there are ways to to keep from using the battery all the time too, there are mechanical linkages like worm gears, you know, that stay where you put them.
Oh.
And so you know you can grip, and it stays gripped until you run the worm gear back the other way.
Right.
And servos can usually go bidirectional. So that kind of a possibility. And there are also flip-flops, bistable devices like computer memories, you know, ones and zeros, ons and offs, that have two states. And you can do that with relays. I used to do it back before I knew electronics. You know, you can have one turn on, you turn this one off, and that one turns on. You know, and so you can have a system that's not always draining power. You know, you just make the transition, and once it transitions, it stays where you left it until you make the other transition back the other way. So there's possibilities there, and I think it's worth pursuing those. Like, I agree with you, Trouble, that it is. That's a good thing to do, to have them normally closed, take some action to open, and then relax and it closes.
Well, another one of our problems is put a lot of strain on our servo. We didn't have it normally closed.
You got a strain on your servo because most of the time it's in the grip position.
If it wasn't normally closed, our servo got really strained and it was working way too hard. So if we kept it normally closed, we kept it a lot happier.
There's a lot of echo coming from you, Arden, but you know what? I saw that smile on your face after you were done talking. Let me see that smile again. Say something, Arden.
Hey, Arden, could you, because you have so much echo, do you think you could type on the side and we could read it out? Thanks.
She knows she really came up with something really good. You know what I mean? It gives you satisfaction, because here we are, all of us. We come here, and this is like not a competition. It's a mutual celebration of our accomplishments.
Well said.
And she came with a really big bang right there. So that was the biggest bang of the meeting, I'll bet you. That was awesome, Martin. Congratulations to your whole team.
Now, I was going to ask, are you using just the standard SparkFun amplifier, or did you build a separate circuit? SparkFun or Advancer? Okay, standard SparkFun. Yeah, that's an easy way to handle it.
The smart way. Yeah.
No sense in inventing the wheel if somebody else has already done the work for you, if you can afford it.
Absolutely, especially in a school project. You know, you only got so much time, and you got a lot of tough work to do. So, especially something as delicate as like sensing muscles. You know.
It sends an invite to Martin Marino as well, and I can't seem to get him to show up in my list. But I'm glad you were able to join, Bob.
Who do you want to go next, Trouble?
Well, Bob was asking to join. I was going to ask him if he had anything interesting that he wanted to share.
Hey, Bob?
Did you have something you wanted to show us today, Nightless?
Yeah, I have two. I have a show and tell and a good report. Or do you want eye candy or brain candy first?
You choose, Les.
All right, I'll give you the eye candy. All right, dun 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 dun. Blinky LEDs. Well, they're not blinking. They change. This is a temperature sensor. It is.
Hold it up higher on your camera.
Oh, yeah. Okay. Hold it in front of
Higher,
me.
more to your left.
More to my left.
Sorry, your right.
My right.
There you go. Right
It's a
there.
temperature sensor. It's an Arduino on top of another Arduino. I'll tell you why in a minute. But let me get my cup over there. My cup runneth over this week. Because I've been working hard, you know, or hardly working or something like that. So it's purple because it's room temperature. When I put it in this ice water, it turns blue. Can you see the blue?
Mm-hmm.
It all looks white to me.
Oh, I can change that with a diffuser.
Dim it down a little bit.
That can be done in the code. Let me see here. I have it on maximum intensity, so let me set it to 1/4 intensity and download that program. Oh, it didn't download.
Yeah, the camera was. I could see some color difference, but I couldn't tell what the colors were supposed to be. It was bright enough that it looked white. One of the whites had a bluish tinge.
Wait a minute. I gotta set this down. Well, I'll tell you what I can do. I can use an e-NABLE hand as a diffuser. That'll work even better than dimming it down.
All right.
How does that work? Can you see the purple at all now?
No. The hand's white to me, too. Oh, now I see a little kind of a purple halo. Maybe you turn the whole card around so the light's shining towards you and away from the camera. See what happens.
Okay. Yeah, I tried to set up something ahead of time, but I slept and didn't. It's purple on my face.
There you go.
Okay. So I'm a purple face, and now I put it in blue.
Yes.
So the face turns
There
blue.
you
can
go.
see.
A great demo. Now you know what to do.
And then I have some hot water out of the tap. And I put it in there, and it turns red. Wait, give it a minute.
Yep.
I think that's as red as this is going to get.
No,
there we
that's
go.
great.
There we go. They got
Great.
red.
Way to go.
So, yeah, it's a nice visual. And it shows how we can use color. These are Adafruit pixels. So they're RGB with any intensity and any color combination, you know. So that way we can, let me just take it out. We can, you know, make red, green, and blue. You know, we can make a red-blue transition like that to indicate temperature, which is a natural color. So this is, let me give you a little more background. John asked me to do Spidey Sense touch, because I was into the Spidey Sense. You know, he's always like getting us to do what we're interested in, and then telling and guiding us gently. You know, so he guided me by saying, instead of doing super hearing for them, why don't you do touch and temperature? I was like, oh yeah, that's so much more useful. So this is the temperature part, and we got touch for next week. I have a sample hand, and let's see. What this circuit consists of is, now this is a big Arduino board with a breakout board on top. But it's the reason I've got the big Arduino board is I'm using it to program a tiny little AT-Tiny85 chip. Can you see that little chip there?
Yeah.
And a few of the parts underneath with the LEDs glaring at you.
Yeah.
So only that chip and those few little parts is what goes on the hand.
Wow.
So it's little. It's only an 8-pin dip chip. Of course, it's available in little bitty packages, but you know, an 8-pin dip is small enough for our purposes.
Sounds great.
And it can go in
so how many sensors can you put on that one chip?
Oh, I'd say 2, but I can use an AT-Tiny, or maybe 3 sensors. I can put 3 sensors. I can put an AT-Tiny 84, which is a 14-pin chip, and have a lot more pins.
Yeah, but you know that I think you're starting the right way, Les. Suppose you think of putting one temperature and one pressure sensor, like on the thumb. That's opposing everything, right? So you may be able to get feedback on how hard you're gripping just by having sensors on your thumb to start with.
Actually, you know what I thought of is I can put sensors on every finger for touch.
Yes.
And then put them all in parallel into the voltage divider. So they sort of mixed and mushed together in a parallel way. If one of them is really strong, the signal gets really strong. If they're all really weak, they're all weak. The signal is really weak.
Huh.
Kind of
That's
thing.
interesting. Yeah, boy, if you can make that work, that's super.
It simplifies the whole thing and runs fewer wires all over the place.
Right, right.
So because the wires have to go where the threads go, you know.
Good thinking.
And there's lots of details in terms of the sensors and making them ruggedized, because this is not going to be a hand that a person uses to play baseball, because the force sensing is, the sensors are delicate. I mean, I figured out a way to make them stronger, but they can be knocked out of position, or it's not for dragging through the mud.
Right, right.
And I figure these kids, oh, go ahead. Well, anyway, I figure these kids, when they first get presented a hand, that's the hand they have. But most of them are will have access to 3D printers in school and whatnot. They're going to have hand over hand over hand throughout their lives, right? So this will be the delicate hand.
Right.
You know what I mean? Yeah.
Yeah.
So
we're learning how we can make them interchangeable. Pull this hand off, put another one on, right?
That's fantastic. That's right. Yeah, fantastic. So they'll put, when they want to do delicate work, they'll put their Spidey sensor hand on.
Right. Right.
When they need to sense temperature, they'll put this hand on.
Yeah. Peregrine Hawthorne, I saw him in Baltimore when we were there in September, and he had a tool belt with 3 different hands on it, plus the one that he had on his car. You know, I mean, there you go. You know.
I saw one where a picture on the e-NABLE website where a kid had made a giant hand that he held with a bar, and he could flex it, and it was, the kid had a normal hand, but he just wanted a robot hand.
They were using it at one of the conventions just to allow people with normal hands to see how it functioned.
Yeah, yeah, that is a great thing to do. And one that's I don't know, I think that must be about 120, 125% Raptor reloaded hand like we had with little kids, and they could put their hand in there and work it just fine, you know, and they had a ball. I mean, it's really fun to see it work.
Yeah. Well, oops, my dessert is running over. Hold on. Got a little ice cream. You know what? I got brain candy for you too.
All right.
The last thing about the eye candy is a friend of mine today was talking. I saw you with a glove over your hand when I walked in, right? A friend with
okay. Yes.
These gloves, gloves they have in the facilities, the thin gloves.
Yes.
Someone was talking about, or John was talking about when we met with the guy from Syria. The people in Arab countries don't like the robotic theme of the hands. They don't want robot hands. They want to fit in. They want normal hands. And
yes.
A friend of mine thought of a way that a normal hand could become, a plastic hand could become a normal hand, would be to take a glove and dye it or color it with a Sharpie marker, their skin tone color, and then just slip it on top of the plastic hand.
I have just in the past week thought to try that with a flexi hand and with a Raptor hand and putting a latex glove, what's the other kind? Neoprene or something. I don't know, but latex. Some people are allergic to latex. You couldn't use it, but latex on top of a flexi hand works great. You know, it gives you a rubber grip. You don't need the fingertips.
Oh.
It gives you a lot of friction.
For the grip.
Grab anything, and the hand I had was smaller than the glove. I couldn't get a glove small enough to really fit it without wrinkles, but that's worth pursuing. Putting a glove, a rubber glove on an e-NABLE hand is definitely worth playing with.
Okay.
Maybe
go ahead.
Another interesting thing that has been discovered is with ABS hands. Nail polish adheres to it really well.
Right.
And they make various flesh tones of nail polish.
Wow.
Huh.
Great idea.
That
yeah,
works.
The acetone in the nail polish, or whatever solvent's there, actually makes the pigment soak into the ABS. And so that's really permanent. That's a good thing.
So then I promised brain candy.
Yeah.
And that is Hand-O-Matic coming at you soon. I made a big effort on the refactoring and getting the Raptor reloaded into it. And the ball is in Ro's court right now because he's doing integration, or he and I together are doing integration of the file that I gave him. We have to meet again, but see, what I did was, the trouble has been that Laird is super busy with his job. We all know that. And Laird has not been able to help me decipher the logic of the cyborg beast. So I was going through it and trying to make it work, and I got certain progress, but it was, when I got to the fingers, it was just, I don't know, it was just too much. I couldn't decipher. You know, everything is rough hewn when you first do it, and my scraper couldn't scrape those rough edges. But so I made a command decision, and I said, you know what? I cleaved the Gordian knot, and I said, I put a conditional, a simple if-then statement that said, if you're a cyborg beast, if you selected the cyborg beast, we're going to use the old logic, and if you selected the Raptor or the Raptor Reloaded, we're going to use the new logic.
Yeah.
So, and that way I don't have to deal with the complexity of the cyborg beast and refactoring that. So this enabled us to move forward.
Yay! Way to go.
Yeah. So it was like a simplification idea, simplifying the work. And
Right. So you know, don't let the difficult one hold you back from being able to use the low-hanging fruit there.
yeah, exactly. Because the thing is, John has more than once put a little. In the last meeting, he said, "I want to know about two things. I can't join the meeting, but I want to know two things." And he listed something important, and the second thing he listed was Raptor Reloaded ? And I'm like, "Oh, this has become mission critical." So I put a big effort into making it happen, and we're in the integration phase now.
Wow, that is so great.
So soon we'll have Raptor Reloaded, and then once we have Raptor Reloaded, we can start adding little doodads, like not little doodads, but big important improvements, like the Whipple tree and the fancy fingers that pick things up nicely, and the parametric hand, and all that stuff. So
You're really a jack of all trades, Les. You know, I do a little bit of basic electronics and mechanical things, but you know, being able to handle the software and all of that too, I'm really envious. Way to go.
thank you. It's from dabbling over the years in different projects and stuff. Although there was about a 20-year gap during the middle of my drinking years when all I did was talk about things and not do things. But I'm back to doing things now.
Yeah,
I'll put up my,
and doing a heck of a job.
thanks. So it's not an arm. It's not a. You know, I mean, art is clearly the winner of the show, but I had a couple things nice. And
Well,
that's all I have to
you're
say.
working on the mainstream stuff, and the arms are still way out in the future. We're not ready for prime time, and so we'll get there. Who knows? Maybe in months, not years. But you know, you're
Let's
working
hope
on
so.
stuff that's going to be put to work by e-NABLE right away, and that's great.
A lot of the stuff that you're working with, Les, reminds me of a lot of the projects that Debbie Loom posts pretty often,
Oh,
playing around with sensors and with.
Oh yeah, the Spidey stuff. I was talking about your
you know, the
pat you
Handomatic.
on the back for the
Yeah.
Handomatic.
Handomatic stuff, but well, that other stuff is what's really fun, and that'll get into the mainstream before you know it.
We had, speaking of the Handomatic, earlier tonight, talking with Jason, I had mentioned that I had had a conversation with somebody several weeks ago about simulating parametric design with OpenSCAD using fixed-sized pieces subtracted out of STLs so that the result would be parametric.
Oh,
You that I was talking to?
It's easy to subtract out materials to make a bigger hole, but if you're resizing a small hand to make a larger, the hole
If you
gets
make STLs that don't have holes,
yes.
then you can subtract out only the amount of space that you need for the pin, or make the attachment pieces.
All right, and all you got to do is find a way to locate them, and that may be easy to do with the software that you use. I don't know, because I can't do the software, but yeah, that'd be wonderful if you could do that.
But I don't know if that was Les I was talking to about that before, or if it was somebody else. I was just wondering if you remembered that conversation, if you remembered who it was with.
I don't recall it.
Okay.
I don't know.
I don't know if any of you guys have any experience with Tinkercad, but I do that with Tinkercad all the time.
A little bit.
That's the way I make these adapters, so that I can take a Raptor hand or a Raptor Reloaded hand and make it fit into an adapter. I just take the STL file for the Raptor hand and turn that into a hole and insert it into the adapter and subtract away a space for it to fit into, you know.
Oh, yeah.
That is so easy to do in Tinkercad.
It's also the basis of OpenSCAD.
The basis for what?
The basis of OpenSCAD's work is the
Okay.
What they call the you know, the words escape me when I have to say them. The Venn diagram thing, the whatever, the union and difference.
Yeah.
You're talking about using the difference. Constructive solid geometry is the word I'm thinking of. The words.
Right.
Because you're saying that Tinkercad has constructive solid geometry.
Yeah, and it's real easy. You don't have to use the fancy words. You just, you know, you have a command that says turn this into a hole, and then you merge the hole with the other object, and it subtracts it.
When you work in OpenSCAD, most of what you're doing is taking basic shapes like, you know, the cube and the sphere and the cylinder, and forming nested difference and union, and the other one, I always forget the name of the other one, union, difference, and whatever, but mostly you use union and difference, nested levels of those, and that creates your object. You also do for loops to make multiple copies of something, and you use modules and stuff like that. So, but anyway, did Bob leave? Oh, Bob left.
Yeah, he left. He wasn't here too long. I'm wondering if he was having network problems or if the echo was getting to him. Skip, I think it is. The echo is coming on your side.
Yeah. I don't know. I couldn't find my little earphone, but.
Oh, no worries.
It's fine. It doesn't bother me. I don't know about anyone else. So,
It wasn't a big deal. I was just mentioning it because that's why I was muting you a minute ago.
so my 3D printer is down right now. And I've got another 3D printer that I'm mailing off to a buddy. He's going to fix it, which is a big task because I took it apart down to the rails and motors. But
What's going on with the printer?
the hot end is broken. The heating element broke.
Mm.
I went to, it's a printer bot, simple metal, and I went to remove the nozzle, and the nozzle didn't twist. The whole hot end twisted, and it twisted the lead off of the heater element. So of course I decided to fix it up by using nichrome wire for a heater element, and I don't know if I damaged the board in the process. So it definitely needs a new extruder. I mean, a new heater element, a new hot end, I should say. and possibly a new board or a new transistor on the board. But probably not. And there's another, I got a Robo 3D printer, which is a lot bigger and is also a good printer. And I'm sending it out to Mike Kelly, who is somewhat of a friend of mine, and he's also the world's expert on Robo 3D printers. You know, I like to joke that you can give him an M3 machine screw, and he'll build a Robo 3D printer around it. So he's going to put it back together. All the king's horses and all the king's men. And
I hope he gets it all. I hope he gets it all working up again for you.
yeah, I'm sure he will, or else it'll become parts. But I'm sure he will. It may have additional cost, but it'll be worth getting it back. And then I'll be back in business. But
so it sounds like we're starting to run out of things to talk about. So if everybody, unless anybody else has something else to bring up, I might just go ahead and go offline or stop the broadcast.
sounds like a good idea.
Thank you, everybody.
All right.
Good meeting.
Thanks for sharing, guys.
Bye-bye.
Thanks to Jason if he's watching this soon after. And thanks for sharing your... sorry about the echo when you were sharing earlier, Arden. But thanks for showing what you're working on. The myoelectric stuff is exciting. And thanks for showing off your new senses with us, Les.
Sure thing, Trouble. And here's a toast to Arden for all her and her friends' hard work.
All right.
Bye.
Is done.